Now, a trinomial is basically any polynomial expression that has three terms in it, just like this one here, ax squared plus bx plus c. In this example, the a, the b, and the c represent number values or constants that would be the coefficients of each of those terms. Now recall that when we were looking at polynomials before, these trinomials can actually come from a product of two binomials through a process of either double distribution or FOIL, and we'll do a quick look at both of those in this video. Double distribution is when you're basically using that distributive property to first distribute the first binomial across the second binomial, and then distribute those remaining terms through each of the remaining binomials. Then you add each of those terms up, and you'll get your trinomial. These middle terms are like terms, so they combine to give me negative 5x. So that's how a trinomial can come from a binomial, and the process of factoring is basically this in reverse. So starting with a trinomial and trying to end up back at my binomial, which is starting with my trinomial and getting back to my original binomial. In order to achieve this goal, we're going to have to figure out first what two numbers to split this middle term into so that we can then undo this process further. So let's take a look at that. We need to figure out what two numbers we can break 13 into in order to start our factoring process. Well, to do that, we use a method called the AC method, and we're going to use this little chart as a helpful tool in helping us figure out what those two numbers are. So in order to figure out what those two numbers are, recall that the shorthand notation for the coefficients of each of these three terms were a, b, and c. The things I'm going to put in this sum and product box, in the sum box I'm going to put the coefficient of my b term, which in this case is 13. And in the product box I'm going to put the coefficients of the product of the a term times the c term. That's where the name AC method comes from. So I'll have the product of 6 times 5, those other two terms, which is 30. And it's called the sum in the product box because the two numbers I'm looking for are numbers which sum or add to 13 and which have a product of or multiply to 30. Well, two numbers which multiply to 30 and add to 13 would be 3 and 10. So these are going to turn out to be the two numbers that I'm going to want to split number 13 into in order to help me along this factoring process. So when I split it up, it looks something like this. I've left all of my terms here, and all I've done is rewritten this middle term as the sum of 3x and 10x. Because again, 13 was representing the sum of those two numbers. Once I have that, my factoring process starts like pretty much any other factoring process, but I'm going to look at it in two parts. I'm going to look at trying to find common factors in the two groups that I have here. So my first group is my first two terms. Its greatest common factor is 3x. There's a factor of 3x in both of these terms. And when I factor it out, what remains is 2x plus 1. You can check that by if I redistribute this 3x, I will end up with 6x squared plus 3x. I'm then going to continue that factoring process by looking at the second group, which has a greatest common factor of 5. And when I factor that out, I'm again left with a factor of 2x plus 1. This part of your factoring process, once you reach this step, this is a quick check to see if you're doing things correctly. If these two terms that I have here in red, 2x plus 1, don't match, you have likely made a mistake somewhere in this beginning factoring process. So if those two things don't match, either your polynomial is not going to factor, or you've made a mistake somewhere in your factoring process. Continuing along, now that 2x plus 1 is common between these two terms, I can factor it out as a greatest common factor. So I pull out my greatest common factor of 2x plus 1, and when I do that, I'm left with 3x plus 5. This is now a binomial. I've completed my factoring process, and I've done this double distribution in reverse. So that will be my final answer. Now, if you remember, there was actually more than one way of doing this distribution, double distribution. We had a shortcut method called FOIL. FOIL, basically a shortcut for double distribution, was a way of kind of avoiding all of that writing in distributing things. And FOIL stands for the product of the first terms plus the product of the outer terms plus the product of the inner terms plus the product of the last terms. And when I add all those terms up, I get that trinomial I was looking for. Well, just like with double distribution, we can do this process in reverse, and that's another method we have for factoring trinomials called the three-bridge method. It actually turns out that that last bridge isn't needed in order to factor something completely.
Impossible.
that the three-bridge method actually starts off in much the same way as the AC method did, in that I'm looking for first the sum and the product. So I have to find the sum and product box exactly the same way as before. The sum will be negative 53, and the product will be 13 times 4. It's that A term times that C term, just 52. So then two numbers which multiply to a positive 52 and add to a negative 53 would be negative 52 and negative 1. So I found those two numbers. Now here is where the two methods diverge. It's basically in the way I'm going to set up my question. The first thing I'm going to do with those inner and outer numbers is put them on my inner and outer arc. So I'm going to first put negative 1 here, and I'm going to put negative 52 here. It does not matter which order you put these two things in. I could have put negative 52 here and negative 1 here. It wouldn't have made a difference. I'd still end up with the same answer in the end. Also, I'm not just going to put the numbers, I'm also going to put the variable that's linked with that middle term. So this is negative 1x, and this is negative 52x. Next, I have my first arc, and that's basically the coefficient of my first term, which is 13 in this example. So I'm going to put 13x squared here. Now this is where things get a little bit tricky. It's going to be a little bit uneasy at first, but once you get a handle on this method, it actually turns out to be way faster than the AC method. The first thing I'm going to look for is a greatest common factor between any overlapping arc. So the easiest one to do is the first two bridges here, this 13x squared and this negative 52x. I'm looking for the greatest common factor between these two numbers to go in this location where those two bridges overlap. Well, I can see this has an x squared and this has an x, so they will have a common factor of x. So I'm going to write that in. And then 13 and 52 actually has a common factor of 13. So I'm going to write 13 here. So I have 13x. And now this is where the process becomes very fast. Once I found that greatest common factor, at either end of these two bridges are basically the factors which multiply to that term. So if this is 13x, in order to get a 13x squared, I'm going to need a factor of x. Looking at the bridge with that, in order to get a negative 1 times x, the other factor I will need is a negative 1. And in order to get a factor of negative 52x, I would have to multiply 13x by negative 4 in order to get negative 52. So at the other end of this bridge would have to be negative 4. So that this trinomial, using this method, factors to 13x minus 1 times x minus 4. Now remember, it doesn't matter which location you put the inner and outer values. You can check that if you did this again with negative 52x in this position and negative 1x in this position, you would end up with the same answer, except these two values would just be interchanged. Let's look at one more example of this three-bridge method in action. So I want to factor this using the three-bridge method. Again, the first thing I'm going to do is write out my sum and product box, and I'm going to be looking for a number which has a sum of negative 9 and has a product of 5 times negative 2, or negative 10. So that's that A term times that C term. Well, two numbers which multiply to negative 10 and add to negative 9 would be negative 10 and positive 1. You can write just one. If it helps you, you can write the positive sign so that you recall that it's positive. As a double check, negative 10 plus 1 would give me negative 9, and negative 10 times 1 would give me negative 10. So those are my values. The next thing I'm going to do in this method is I'm going to write this trinomial as a binomial and put in my three bridges. Now again, it doesn't matter where you put your inner and outer values. So I'm going to put my 1x, again, x because that's my middle variable. I'm going to put my negative 10x out here. On this top bridge, this first bridge, will be the same value of my first term. So that's 5x squared. Once again, where these two bridges overlap, I'm looking for the greatest common factor of these two values. And the greatest common factor here will be 5x. And I'm going to go through each bridge to find out what factors would have to be paired with this in order for this product to result from them. So if I have 5x here and I want a 5x squared, I'm missing a factor of x. And I have a 1x here, so I'm missing a factor of positive 1. And I have a negative 10x here, so I'm missing a factor of negative 2. Again, negative 2 times 5x yields negative 10x. That's how I'm figuring out what these numbers are. Given 5x, I would need a negative 2 in order to get a negative 10, which means that my final answer is 5x plus 1 times x minus 2.